Hello and welcome you all in the course of Probability and Statistics. I am your instructor Hardik Joshi. Now, today in this lecture we should learn about or say normal distribution. But more precisely, we have to see with the help of this normal distribution how we can find out exactly the probability of any of the random variable, so continuous random variable. That is, our topic is, say we have to see the example of normal distribution. So before dealing with the example, just we have to recall the mathematical formulation corresponding to this Gaussian distribution, that is normal distribution. So we know that the probability density function, that is PDF, corresponding to this Gauss distribution is given by the mathematical formulation. So f of x mu sigma is equivalent to 1 upon sigma to square root 2 pi into e raised to minus x minus mu whole square upon 2 into sigma square, where this x, mu and sigma are the parameter of this Gauss distribution, where x is represents or x is a variable, it depends on us. We have to find out the probability corresponding to which, that is the distribution lying between which range. The second parameter mu, that is mean, and the third and last parameter sigma, that is the standard deviation. So these are the mathematical formulation. But you know, in this different distribution, normal distribution, what is the different thing? Generally, whenever we have to find out the probability corresponding to any of the distribution, we must know that mathematical expectation, because that mathematical expectation, that is PDF, probability density function, we have to remember, and by using that expected formula we have to solve the example. But here the one different thing is that we do not remember this Gauss distribution formula, because the Gauss and Laplace has developed one of the strategy. They have to develop one table. That table is known as the standard normal table, and we have to see they have to prepare this standard normal table corresponding to this distribution, and these are sometimes also known as Z distribution table. So we know that whenever we have to find out the probability of any of the continuous random variable x lying in some particular interval, so what we have to done, we have to just plug in the value of that value x, value of mu and value of the standard deviation. But here we do not remember that formula, because the Gauss has developed this particular table. Now this table can be obtained for each and every value by plugging in the previous formula, and they have to prepare this table. Now, as just for one example, I have to explain one thing. If we have to find out the probability of random variable z lying in between the interval 0 to 1.25. So see in the margin, there are the normal distribution, say graphical representation, and we have to highlight the portion by blue color. Now that blue color represents the area lying between, say, z equal to 0 to z equal to 1.25. Our aim is we have to find out the probability of that portion. So ultimately we have to plug in the value of x, mu and corresponding standard deviation in the previous formula. But no, here the different thing is we have to use this standard normal table. So we have to find out the area lying between this particular under the curve. So the value of z is 1.25. So see the first row. The first row represents the z corresponding to the first value, right hand side is 0.00, the next is 0.01, 0.02, 0.03 and so on 0.09. And now the first column, that is corresponding to 0.0, 0.1, 0.2, 0.3 and so on 1.1, 1.2 and up to 3.4. So they have to prepare this table, and we have to interested to see the probability when z is 1.25. So what we have to done, see in this slide we have to highlight by say red, just like a ellipse. So in the first column we have to highlight say 1.2, and in first row we have to highlight say 0.05. So whenever the point of intersection lies corresponding to 1.2 and 0.05, its value is just like say approximate say 0.3944. It means that the area under the curve which shown in the margin is 0.3944. So ultimately you know the knowledge how you can find out area under the curve. You have to use the little bit knowledge of the calculus, but right now there is no need. We have to find out the area under the curve by using this distribution table, that is standard normal table. So these are how we can use the standard normal table. I have to explain. Let's see the example. What is the probability that the standard normal variable z will be? The first option greater than 1.09, the second option less than negative of 1.65, third one is lying between so one particular range say -1 to 1.96, and the fourth one is lying between again 1.25 to 2.75. So one by one we have to dealing with each and every option. So let's start the solution. So we have to consider the first option, that is greater than 1.09. So sake of conveniency, again I have to write down the first option greater than 1.09. Remember, I have to already tell that these are the standard shape of this normal distribution, and we have to consider the middle line say z equal to 0. On the just right hand side we have to consider the line say z equal to 1.09, and we are interested to find out the probability of z when is greater than 1.09. So it's definitely all the portion which lies from the right hand side of the line say z equal to 1.09. So we have to highlight by say shaded say blue color. So this shaded area is represent the probability when z is greater than 1.09, and our interest to find out the probability of that portion. So let's start with the very basic concept. So the total area under the curve is equal to 1. These are the standard fact for each and every example. The total area covered by this normal distribution is exactly equal to unity, that is 1. And we know that this curve is symmetric, that is the line z equal to 0 is split the normal distribution into two parts. So definitely we have to say that the probability of this left hand side portion as well as right hand side portion is equal to 1 divided by 2, that is 0.5, because the reason is the curve is symmetric. So the area between z equal to 0 and 1.09, remember our interest is we have to calculate the area when z is greater than 1.09, but we have to use just little bit different strategy. We know that the area of this right hand side portion is 0.5. So instead of finding the area of z is greater than 1.09, what we have to done, we have to find out the area which lying between z equal to 0 to z equal to 1.09. And we know that the area of this right hand side portion is 0.5. So what we have to done, we have to find out the area lying between z equal to 0 to z equal to 1.09 and subtract it from 0.5. So our job is done. So here we have to write down the area lying between z equal to 0 to z equal to 1.09 is equivalent to 0.3621. Now just remember it, this value 0.3621. I will show the same thing how we can see or how we can find out this value from the distribution table. So just remember the value 0.3621, and that is the area, or is between, say, z equal to 0 to z equal to 1.09. So we have to say that probability of z greater than 1.09 is equivalent 0.5, because the probability of right hand side portion is 0.5, minus we have to subtract the probability of z lying between z equal to 0 to z equal to 1.09, is 0.3621. So ultimately we have to conclude that the probability of z when is greater than 1.09 is equivalent 0.1379. So next I will show you how we can obtain the value of z lying between 0 and 1.09. So this, I will again show you this distribution table, and I have to highlight, say, first column 1, and in the first row is 0.09. So when we have to find out the point of intersection of this one and this 0.09, so it splits the value of 1.09, and now it's exactly 0.3621, and this value we have to use to subtract from 0.5. So in this manner we have to see the value of z in the z distribution table. Let's see the second option. Here we have to find out the probability of z when is less than negative of 1.65. So ultimately we have to find out the area. Remember, z is less than negative 1.65. So somehow these are z equal to 0, these are z negative 1.65. So less than negative 1.65, that is this all area, and definitely is unbounded. So we have to highlight by this shaded blue color. So our goal is we have to find out the probability of that portion, that is area under the curve. But again we have to use the same strategy. We know that the area of this left hand side portion is say 0.5. And now again we have to tell you the one important thing. Whenever we have to see the probability in the standard normal table, there is nothing like negative value. There is nothing like negative value. We cannot see that what is the value of z when it's negative 1.65. So in z distribution table there are nothing like negative value. So again we have to use one of the property of this normal distribution. We know that normal distribution is symmetric. So instead of find out the probability less than negative 1.65, we have to find out the probability of z when it is greater than 1.65, and definitely it's same because the curve is symmetric. So first of all we have to find out the area lying between this negative 1.65 and 0. So again by using the same argument, there is nothing like negative. So instead of this negative 1.65 to 0, we have to find out the area between 0 and 1.65. So again we have to take help of the distribution table. So we have to say that the area between 0 and 1.65 is equivalent to 0.4505. This value we have to take from the standard normal table. I will show you later. So since the area of the left of the curve is 0.5, so probability of z when is less than 1.65 is equivalent negative 1.65 is 0.5 minus 0.4505, so is approximately 0.04. So next I will show you how we can obtain the value of z lying between 0 and 1.65 is equivalent to 0.4505. So see, so 1.6 I have to highlight, and in first row I have to highlight 0.05, and the point of intersection is exactly shows the value 0.4505, and that value we have to use to find out the probability when z is less than negative 1.65. Let's see the third option. Find out the probability when z is lying between negative 1 and 1.96. So the probability that the random variable z is lying between -1 and 1.96 is shown in this graphical representation. So we have to find out the area of this shaded region. So area between -1 to 1.96 is equivalent to area between -1 to 0 and area between 0 and 1.96. So again we have to use the same argument. There is nothing like negative in the standard normal table. So instead of finding area between -1 and 0, we have to find out area between 0 and 1 and area between 0 and 1.96. Then add up, then our goal is done. So the probability of z lying between -1 and 1.96 is equivalent probability of z lying between -1 to 0 plus probability of z lying between 0 to 1.96. And remember this two value, that is approximate 0.34 plus 0.47. I will show you how we can obtain from the distribution table. And by adding them, we have to get the probability of z lying between -1 and 1.96 is equivalent 0.8163. So next I will show you how we can obtain this two value, that is 0.34 and 0.47. So see here, the first say red highlighted portion say 1 and corresponding 0. So we have to say that the probability of z lying between 0 and 1 is exactly equivalent to probability of z lying between -1 and 0 and is equivalent to 0.3413. Similarly, probability of z lying between 0 and 1.96. So we have to highlight at 1.9 and 0.06 and corresponding point of intersection is 0.4750. So we have to use these two values, 0.3413 and 0.4750 from this distribution table. Now the fourth and last option, find out the probability of z lying between 1.25 and 2.75. So that can be shown in this graphical representation by this shaded area. So area between z where is lying between 1.25 and 2.75. So what we have to done? We have to find out area between z equal to 0 to z equal to 2.75. Then we have to subtract the area between z equal to 0 to z equal to 1.25 and that exactly reads the area between z equal to 1.25 to 2.75. So probability of z when is lying between 1.25 to 2.75, it's equivalent to probability of z from 0 to 2.75. Then we have to subtract the probability of z when is between 0 to 1.25. So again we have to take a help of the normal distribution table and we have to obtain these two values, say 0.4970 and 0.3944. I will show you in the next slide how we can obtain that value, and by solving that we have to obtain the probability of z when is lying between 1.25 to 2.75. It's exactly equal to 0.1026. So see here, so corresponding to 1.25, so we have to highlight the 1.2, 0.05, so corresponding value is 0.3944. Similarly, corresponding to 2.75, its value is 0.4970. So we have to use this two value, 0.3944, 0.4970. So thank you so much for paying your attention.